This is kind of a new experience. Normally I'm used to, like feedback, working with folks, talking alongside them, exchanging information. So this is a little different, right? I'm just kind of like walled off in my own personal bat cave. And hopefully you are ensconced safely in yours as well in this interesting time that we're living in. But anyway, so I think I'm recording. It looks like I'm recording and streaming. So so we'll go from there. I was actually asked to just kind of let you look behind the scenes a little bit and see, some things that I'm working on. And this is actually for some material that I'm putting together for, a couple of new talks that I'm preparing. So this is very much a rough edged work in progress. Some of the introductory stuff is obviously not, but as far as just how I'm putting it together is still, kind of edgy and, sharp pointed objects sticking out everywhere. So yeah, welcome. You'll get a little look inside my mind. I apologize in advance for how cluttered it is, but it's home, right? So this talk, I think I closed it out, but the idea behind this talk was just to talk about some of the different communications options that you have between and among various different Spring Boot based microservices. And it kind of occurred to me because we talk about a lot of different things, a lot of different options. And I say we, the royal we, right? All of us. Many times when we come out of the monolithic world, we start talking about, getting different services to talk to each other and exchange information. And usually we kind of start off with HTTP based interactions, and we kind of, that frankly, many times that works just fine. But when it doesn't work just fine, or we start looking at options for one reason or another, we start thinking, well, what is available to me? What could I do differently? What are the advantages, disadvantages? How would I implement that? What do I need to implement that? And it got me thinking, I don't want to pass judgment on any one thing in particular, because all of these things that I'm going to be talking about and many, many more are actually put to very good use daily, worldwide, in various different circumstances. So I try to, when I'm going through this, kind of think in my mind, and I'll share as I go, kind of narrate as I go, in terms of what some of the possible drawbacks or disadvantages are, or advantages. But again, everything is relative, and everything depends largely on your particular circumstances and setup. So, again, your mileage may vary. But I think to start out, what I would kind of like to do is just go with a pretty simple use case, which is just to create a couple of services and get them talking, just at a very basic level. And then we'll kind of riff on that from there. So, of course, we start with the Spring Initializer, as most folks know, but you don't have to. I mean, I always say you can write your own Spring Boot based applications entirely by hand. You can create your own bespoke, artisanal, handcrafted Spring Boot applications. Not the best use of your time. It's certainly not very gratifying, really, by the time it is all said and done, because what we really want to do as developers is get down and produce real code of value. And just recreating the wheel every time, not a lot of value there. But if it makes you happy and you've got a Saturday to kill, why not, right? But we typically start here with the Spring Initializer, and you can curl this, you can HTTP this, you can access this via various IDEs. I like to come here because the initializer does have a couple of nice features, and I delight in pointing these out. One is this, so light mode and dark mode, which I know is a very small thing, but if you live in dark mode as I do, when you flip open the initializer and you see that, it's a little jarring, no pun intended. So I like to keep everything dark mode if at all possible. And vice versa, if you like the bright lights, that's great. Keep it all in light mode. So that's fine. But it's nice. It's just a nice little extra feature, small feature, but super useful. And then I'll also show you the Explorer here for the projects, which I think a lot of as well. Not, probably the highlight of your whole year, but maybe the highlight of your whole week. I don't know. It's just a good extra feature. So I'm going to start off and just create a couple of Spring Boot projects. I'm going to use Maven because I'm typically a Maven developer when I use Java. When I when I use Kotlin, I go full on hipster, right? I go with Gradle, and I don't know why. Well, I'll probably do know why, because when you create via the initializer a Spring Boot Kotlin application, it creates the build.gradle.kts file. So it's Kotlin, using Kotlin for the scripting language instead of Groovy, which, if you're creating your Groovy app and you want Groovy in your build.gradle file, that's great. When you have a Kotlin app, I don't know. It just seems like you ought to have Kotlin all the way through. So, yeah. But yeah, for Java, I typically stay with Maven. Again, do what makes you happy. I'm going to stay with the current version of Spring Boot because there's nothing that I necessarily have to reach forward to use today. Because again, I'm going to be keeping this fairly simple at certain levels and then just kind of expanding out from there. So that'll work. I'm going to just change the group to the Hecklers if I can type. Let me make sure. Yes. Okay. So audio is great. Hey, I appreciate that. Hey, everyone. Yeah, I just, let's see, maybe pop your font. Yeah, let's try that here. I was gonna say, when I go into the ID, I definitely do, but now that you mentioned that, I'll ask you at that point again, just to verify that the font is large enough, because it may or may not be. I think I did ramp it up for a talk or a couple talks that I did Monday, but streaming and different setups are different. So, all right. So we're going to stay with the hecklers.com for the group, because why not? I'm going to create a couple of things. So we'll call this thing 1 service and thing 2 service, right? If any Dr. Seuss fans out there, I'm a big fan. Yeah, Dr. Seuss rocks. Okay, one of my favorite doctors, probably not in line with any of the Who's, Doctor Who, but or the Doctor if you prefer. And I prefer, but okay. So I'm going to stay with jar packaging and Java 11 because it's the current LTS version of Java, but we do support back to 8 and we go up to the current version of Java, which is 14. So yeah, again, do what makes you happy. I'm going to add a few dependencies here. I'm going to bring in Spring Web so we can do some web applications, reactive web. And then I'm going to bring in Lombok because I'm a lazy developer. Those of you who know me know what I mean. But lazy good, not lazy bad. At least that's what I keep telling myself. And that way I can concentrate on, keeping things nice and concise versus writing pages and pages of boilerplate for getter setters and all that stuff. So let's see. What else do I want to bring in? RSocket maybe. And then Cloud Stream. Because I do want to show different ways, again, of communicating between applications, and Spring Cloud Stream is a great option. And then, of course, with Spring Cloud Stream, you need a binder. It even tells you that when you select it. And I'm going to bring in Rabbit and Kafka and get our binders. In fact, here's the tip-off right here. Requires a binder. So Kafka, RabbitMQ, Solus, PubSub Plus, what have you. So good options. So that gives us a few different things to play with. And as I said earlier, I'm kind of putting this together for some talks, and I want to make sure that I have kind of the things that I want to bring in. I'm not going to get to everything, and I've kind of resigned myself to that for a couple of reasons. One, we only have so much time. And two, because some of this stuff, I mentioned edges poking out and wires exposed. Some of it has more wires than others sticking out, and I'm just not quite ready to show some of that yet. So, yeah, I'm sure we'll have plenty. Somewhere between 15 minutes and an hour and 55 minutes, but probably closer to the middle ground on that. So here is what I was saying on the Explorer. This is a very nice feature of the Spring Initializer. And I do want to say that whether you access start.spring.io via curl HTTP, via an IDE, via the page here, you get the same artifact. It's consistent. So if your coworker who, well, I started to say on the other side of the wall from you, but let's face it, on the other side of the city from you in this case, or maybe the country or the planet, but maybe she likes to go through HTTP. I'm fond of that. That's great. Maybe you like to go to the page. That's actually my favorite because of things like this. But it doesn't matter because the same consistent artifact comes out either way. But this is a nice extra feature of going through the actual Spring Initializer page, which is that you can check out the project structure, everything in it. You can take a look at how it's going to be created. This is kind of I think the icing on the cake, because you can take a quick look at the dependencies you have and see if you've missed anything. And sometimes, if you've created a project and you're like, oh, I need to add in a particular dependency, can't remember what it was, can't seem to search for it and find it, I just go here and I just throw the dependency that I'm wanting in there, pull up the Explorer, and bam, there it is. There it is. And I can just copy paste it into my current project and life goes on merrily. So it's a nice little extra thing. You don't use it a lot, but when you use it, it's super, super handy. So I'm going to just go ahead and create this. Oops. I don't want to do that. I want to generate it. And we'll drop that right on the desktop. So we've got thing 1. And I'm going to create thing 2 since I'm in the neighborhood. So Dr. Seuss would be proud. Thing 1 and thing 2. Okay, so I'm going to open those up. Boom, boom, boom. And no, come on. So let's open that. There we go. Okay, let's blow that up. Close that out. Close that out. And we'll open our POM. IntelliJ is having a little trouble keeping up with me for some reason. I guess because I have about a million things running on my machine at this point in time. Come on. That shouldn't affect anything, should it? And then I'm going to go ahead over and open up my thing 2 service, unzip that. 2 monitors, fun stuff. Okay, so thing 1 and thing 2. All right. And here too, I'll go to the POM and the application properties and the application code. Okay, so super, super simple. If you're new to Spring Boot, the Spring Initializer doesn't generate code for you so much as it generates a project. I mean, it does obviously create this massive amount of code right here. This one line right here creates your main application class main method. That's it. But what it does do is set things up really nicely for your dependencies and your project structure and all of that to save you a lot of time down the road. So that's kind of nice. All right, so that gets us, I think, off to a rollicking good start. So let's see what we want to do. So I typically, since we have 2 applications that we're going to want to run at the same time, the default for Spring Boot applications when they start up is to start up on port 8080, listening on port 8080. So we don't want any kind of port conflicts. So what I'm going to do is just do a server.port. And of course you can specify 0. And when you do that, Spring Boot will say, hey, look, let me find an available port, any old available port that's out there that's unused, and use that. But since I want to be a little more consistent today, I'm just going to, line up my fingers on the keys, and we'll put that on 8090. So now, if I go over to thing 1, I could do that. Let's see. Close that out. Nice. All right. So if I go over to thing 1 and same thing, server port, and we can leave this on 8080, right? But we saw that's the default, so I really don't even need to put that. But yeah, there it is. So just our little reminder, we've got one on one, one on the other. Okay. Now, let's start with thing 1. Let's baby steps. So what I'm going to do right now is just create a REST controller. And we'll keep this simple. So a REST controller, we'll start off with a base mapping of, let's say, things. Why not? Okay, so let's see, class thing 1 controller. And we will return, let's just do a get mapping of thing 1. Let's keep it straight. So in order to retrieve a thing 1, we probably should have a thing 1, right? So we'll call this thing 1 and private string ID and let's say, do I want to stay with name? Do I want to keep a description? Let's go with the description, ID and description. So it's thing rule, right? All over again. So there we go, description. And since I'm using Lombok, I want to make this a data class, which means Lombok will provide my getters, setters equals hashcode toString methods. I'm also going to ask Lombok to provide a noargs constructor and an allargs constructor, which means for the allargs, noargs is probably obvious, but if you're not familiar with Lombok, by annotating a class with an allargs constructor annotation, Lombok will create a constructor with a parameter for each of your member variables. So that gives us a constructor with both, right? So that's kind of nice. So we have thing 1. I'm also going to create a thing 2 because we're going to be interacting with the thing 2 service here momentarily, and we'll, just to make it easy, we'll keep them fairly close here. So But for now, we're just going to do a get mapping on thing1 and return a thing1. Get thing1. Return new thing1, and we'll just use uuid.random.toString, and this is thing1. All right. We should be happy, right? This is thing1. All right, so I'll go ahead and insert that. That gives me time to take a drink of coffee, and you as well. Cheers. And let me check the, see if we have any comments as soon as I can find the comment screen again. Okay, I will be trying to check that from time to time, but no promises because I get excited about the code and then I don't check back. So apologies if I don't see it right away, but I will come back to it at some point. So let's see. Perfect now. Good. Oh, which season of Doctor Who? Well, all of them, but to be honest with you, I didn't, I started with New Who. I saw the Christmas special with Tennant, so number 10. And I'd heard about it for years, never had watched it. Just, feel terrible saying that. I just feel dirty. Sorry. But when I saw that, I realized I needed to start somewhere, and Doctor Number 9, which was Christopher Eccleston, I started watching at that point with his beginning, if you will. And I didn't realize until later when I went back and looked how many nods they had to the classic Who in that one season. It was kind of amazing. But yeah, Eccleston was amazing. I thought he couldn't be topped. Then in came Tennant. And after like 3 episodes, I was hooked. Thought he was the best Doctor. Still think he's the best Doctor. But he's, I guess, my Doctor. Maybe it's because I did see him first. I don't know. But yeah, every Doctor has been amazing. I tried to go back and watch the classic Who, and I can appreciate each of the classic Who Doctors as well. It's just a lot harder because you could tell the budgets were not there, and frankly, the effects of the time weren't there. So. But 10's the guy. 10's the one. But yeah, everybody has been great. Capaldi, I think, got a lot of flack, and I thought he was amazing. Jodie is awesome. And I will say, I think she suffers from the same thing that Matt Smith suffers from, which is some of the scripts aren't that great. But, you've got great acting, and they do what they can with what they're given, right? So yeah, I'm looking forward to more and more. But yeah. All right, so let's see. Okay, well, I'm going to have to come back to the other stuff because let's see. No Flapdoodle. Those of you who know me know I love Flapdoodle, which is the embedded Mongo. Nope, none today. Well, if we have time. But it wasn't exactly what I was thinking of for these particular sessions. So yeah, maybe another day if not. So, okay, let's go back here. Oh, we're running. Of course we are. Probably been running for like minutes now, but all right. So I'm just going to use HTTPy. It's curl for humans, mortals, whatever, because it, like Spring, is opinionated. You don't have to like curl type in localhost, blah, 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 because it assumes if you don't type a host name, it is localhost. So that's kind of nice. And we're accessing 8080. Let's see. Let's things. And thing1. So let's see if we've got that. And actually, you know what? I need to get in this habit of just doing a bare retrieval so I don't have to, no pun intended, so I don't get all the extra, the headers and stuff. But yeah, so we see that's working, and that's not really Interservice. It's just a nice starting point to make sure that it's got a heartbeat. So we're accessing something one on thing1 service from thing1 service. Okay, but that's not overly exciting, right? Let's get these two services talking as we promised. So let's see. I'm going to just grab these, and we'll copy those over. I could retype them, but yeah, this is super fast and efficient that way. All right. So actually, here in Thing2, same thing. I'm going to create a no, close that. REST controller. Come on, keep up, IntelliJ. Request mapping / Thing2. What did I call that? Let's see. Thing2s, maybe. I don't know. So I think I just called this. Yeah, just things. Okay. Yeah, that's fine. Thing2s. That'll work. Class. And this will be a Thing2 controller. I'll probably change the wording, the name on that, just to protect the innocent later. Because usually naming is one of the hardest problems, right? You start down a path and you think this is brilliant. I've got the perfect name, and 3 minutes into it, you realize it's a terrible name and you want to change it. So yeah, no promises. All right, so I'm going to do a get mapping, and we'll call this thing2. So we're just going to return a thing2, thing2, get thing2. Whew, typing is just already shot. There we go. Return new thing2. Seems like there's a delay here, but in my keyboard or the streaming or something. But so I don't know. We'll find out. To string, and let's see. This is a thing2 from thing2 service. Boom. Okay, so that seems like it should work. I'm going to start that, and we'll go back to our thing1. And let's see. So I actually want to just do a, yeah, we'll leave it. Won't hurt anything. Get mapping. Wow, it is terribly sluggish. How weird. Thing2. Okay, we're going to return a thing2. Thing2, get thing2 from thing2 service. Hey, look, I'm naming things just like super long, method names. That's perfect. Okay, so I need to somehow return a thing2 from thing2 service. Well, let's start by connecting the dots here. So I'm going to create a web client. Web client, yeah, it is terribly sluggish. That's interesting. Equals web client dot create, and we'll point to localhost 8090, right? And actually, I'm going to be pointing to thing2s, so I'll just add that in because everything will be beneath that. Thing2s. Yeah, that's nice. Okay, so return. And I'm going to use that client. And by the way, this web client is the reactive web client that comes in as part of Spring Web Flux. Now, I guess I should back up a little bit because we're not getting into the reactive programming just yet. However, if you've used Spring and Spring Boot for any length of time, you're probably familiar with Feign client and REST template and things like that. Great stuff, right? But going forward, there are kind of two pillars that Spring Framework and Spring Boot are built on, which are the Spring MVC pillar and the Spring Web Flux, or Spring Web MVC, if you will, for the packaging, and Spring Web Flux. One is not going to replace the other, right? They're both very important, but they're both similar. They're both complementary. But it kind of makes sense to look at things in the best way forward for any kind of code you develop. And I say you, but within the framework, within Boot, and of course that extends outward, right? So when you go from when you consider the two, one is a blocking model and one is a non-blocking reactive model. It's very easy to go from a non-blocking model to a blocking model. You just add typically a .block operation. You just wait, right? It's just a matter of just waiting. But going from a blocking model to a non-blocking model is considerably harder because then you're kind of artificially inserting some things in there to not block when you have things that are already, well, there are stop signs down the whole path and you're pretending there aren't, right? So it made sense to kind of consolidate the efforts for clients into a single client. So web client is the way forward. It starts with a non-blocking reactive foundation, but it's very easy to take that to a blocking model. So thus the web client, right? So that's part of Web Flux, but we're going to be using it here in plain, straightforward blocking Spring MVC. So I'm going to use the client. I just created a web client pointing to thing2 service, right? So I'm going to do a client.get, and I'm going to add to the URI because I actually have the base URI there, but if you remember, I'm going to be adding thing2 to that, right? So I just add that. It's cumulative. It just adds on. And I'm going to retrieve the results of that, which are a mono in this case, and it's a mono of thing2. Now, don't pay a lot of attention to this just yet. I will say that I keep having to kind of dive in just a little bit, just toe into the waters for reactive, but it kind of makes sense, right? In a blocking world, we have typically when you think about a return value of a method or a function, if you think in terms of Kotlin. All good. But you typically you'll return an object of type T, for instance, or maybe an iterable of objects of type T. So you have, you're returning one thing, 0 or one thing. In this case, you have either aren't returning it, haven't returned it, or you are, or you're returning a small grouping, a collection, if you will, of these things. So in the reactive world, the reactive streams specification actually doesn't differentiate. The publisher interface is just, it returns something, 0 to n, 0 to infinity. But within Project Reactor, which was the effort that Pivotal has led, and VMware, and has become the foundation of Spring Web Flux and many, many other commercial and open source packages out there, Project Reactor does differentiate, because it makes a lot of sense to differentiate when you expect one thing versus a bunch of things. And of course, when I say a bunch of things, it can be a small collection, a handful, 5 or 10 items. It could be 500 items, 5,000. It could be an infinite number of items that are returned, let's say from a method, over an infinite amount of time. It could just be a never-ending stream of values that keep coming down the pike. But that's still fundamentally treated differently than something you're expecting a value to return and one and done. So the mono in this case is just saying that we're going to be getting back a thing too. We're just asking for one thing to come back. No pun intended. And then what I'm going to do is just block, which if you noticed, when I type in block, you see that that actually returns the object of type thing too. So that's how you go from that non-blocking to the blocking mode. Now I'm actually going to insert something in here, because when you have a publisher, you can also log what's coming through that publisher, which is kind of nice. It's like well, you're logging. It's so simple. So I'm going to go ahead and just restart this, and we'll see what we get. Okay, I'm kind of scanning the, well, what is, boy, everything's sluggish. I'm beginning to wonder if, good thing I closed out Slack, right? Because, I mean, as sluggish as this is with the recording software and everything running, and I mean, with Slack, it probably would have just died by now. Slack. I was just checking to see where we were. I'll have to come back to some of the, like I see there's a big question over there. The print's really small because I've got it over on my tiny little monitor off to the side, but I will come back and answer some of these. Let's see, how to set up a Spring Boot project. I mean, typically I'll address this in more detail later, but typically the starter POM is kind of how you manage your dependencies and the version synchronization. So if you don't have that, you're doing a lot more manual than perhaps you would have to, or maybe you would even want to. Not saying you can't get there from here, but a lot of the good stuff comes because you're letting the dependencies. I always say the simplified dependency management is one of the 3 superpowers of Spring Boot, because it allows you to not have to focus on version synchronization or what goes in to make a particular capability. You think in terms of the higher level capabilities, and that top level is what brings all those other things together. So yeah, I'll come back and we'll talk about that in more detail down the road, but hopefully that gets you kind of thinking in that direction. All right, so we're back up and running. So let's see. So thing 2, right? Isn't that what I said here? Thing 1 service, thing 2, yeah. Okay, so yeah, this is a thing 2 from thing 2 service. So what we basically have is thing 1. We're pinging thing 1. We're hitting an endpoint on thing 1 service, and saying, hey, give me a thing 2 from thing 2 service, and which then it uses our web client to go and retrieve that, accesses localhost 8090 thing 2s for the thing 2 service, I guess, thing 2s, and then appends thing 2 to it, retrieves what it gets back, and then passes it on. So yeah, again, pretty simple stuff. So let's see. Yeah, that's probably good to get us going there. And wow, I didn't realize we're motoring right along in time too. So let's go ahead and roll forward here into the reactive space, or at least partially in the reactive space. And I'm getting pop-ups. That shouldn't be happening. There we go. Okay, so killed that. All right, or quietly silence that. Nicer way to put it. All right, so we have thing 1 service, thing 2 service. Everything is blocking, non-reactive. I'm just going to go ahead now and, you know what? I'm going to leave this as it is for the time being. And we'll go to thing 2 service. Okay, so rather than return a thing 2, I'm going to return a mono of thing 2, which again is one value, right? It's just a reactive streams publisher of, and we're returning a value of a thing 2, right? So we'll do a mono.just, and we're just going to return this value. Let's clean this up just a bit. Yeah, that's not terrible. All right. And then I'm going to go to my WebFlux. Well, typing helps. Just going to comment that out. Don't have to do this, but this keeps it. This then lets us use Netty by default. All right. Got to keep the jet fuel going here. I do hope you have your coffee. All right. Wow, this is terribly sluggish. I've not had a machine this sluggish since I was running on 8 gig, I think. But I guess if you have that many things going, it's just going to get a little slow. So, all right. Go ahead and restart thing 1. Yeah, wouldn't really matter, but get in the habit. Okay, so we're running on thing 2. Thing 2 service is running. So let's go ahead and see what we get here. I'm not going to make any changes to thing 1 initially. I'm just not going to go there. I'm just going to leave it. And why is this not doing anything? Fine. Let's see. I'll just hand type it. Why not? Okay. Now, here's something I wanted to point out, because I think this is, it's not a big deal. It's just kind of a nice thing. Because if you remember in thing 2, which, by the way, we go back through here. Boom, boom, boom. Yeah, interesting. Okay, well, I'll have to... Oh, that's why. Yeah, I'll re-import. Okay, so if you notice, we're returning a mono of thing 2. So that's exactly what's going to be passed back from thing 2 controller, or from thing 2 service, when we ping it. And yet, over here in thing 1 service, we're actually retrieving this, and we're still getting back a thing 2, right? How's that possible? Well, again, it goes back to the fact that Web Client pulls down by default a publisher and then blocks and creates the actual object type from that. So it does the content negotiation and navigation on your behalf, which is kind of nice. So let's see. We go back here. Should have restarted by now. Yes. Perfect. Okay. And yeah, this is what I was looking for right here that I couldn't find, because now we're running on Netty, which, any Servlet 3.1 compatible engine will work just fine. However, Netty is the default under WebFlux for a reason. It's just, it's super proven, right? It's great. It's performant. It's well proven in terms of its scalability and performance and reliability. So yeah. All right. So that's kind of that half measure. Let's go ahead and go back to thing 1. And to convert this to where we're just dealing in terms of mono, we can just, well, actually, I'll just remove this. And then I'll return up here and do a mono thing 2, right? Boom. And that's really just as simple as it is. So let's say, oh, I probably should do that here too. Doesn't have to be done, but I like to keep things consistent. So we'll do our Maven re-import. And I'm noticing how behind that screen is, but yeah, hopefully the the sound, the audio is roughly with the video. I don't know. If not, that's going to be a little confusing, but all right, so let's see what we have now. Oh, whoops. Let's see. So, yeah, I just got a little ahead of myself. Okay, so we see that it's working, which is exactly what it's supposed to do, right? So we've kind of covered the blocking approach. We've covered the, hey, I'm still blocking on the front end, but I'm querying a service behind the scenes, which is returning a Reactive Streams publisher. Not getting a lot out of that deal, but you know, it's possible to do. Now let's see. Let's go back to here and let's add into this just a little bit. Okay, so we've retrieved a single value, a thing2. Let's play around with this and see what else we can do. So we're going to get mapping and we're going to return thing2s. Oh, that's things. Thing2s. This isn't going to be confusing at all. Again, naming is not my strong suit. All right, so thing2. So we now have a flux of thing2s that we're going to be returning. So a stream of them. So let's see, get thing2s. And we need some thing2s. So let's see, I'm going to just create some things here. So private list of thing2, let's say, and we'll call this thing2s, things. That'll work. No need to get fancy. No, come on, IntelliJ. There we go. Yes. Equals list dot of. Let's do the names, shall we? Names. So let's do string. Let's do a list of strings. So list of, and I'll just use the phonetic alphabet used by airlines and all the government agencies and people who are reading my mail and looking into my sock drawer and stuff like that. So let's see, Charlie, Delta, and we'll end with echo. Kidding. Okay. All right. So we're going to just return a list of thing2s, right? So, so let's see, return. So let's do a flux dot from stream. Why not? So we'll do a names dot stream. This should work, and let's map that. So we'll take the name and we'll do a new thing2, and we'll use UUID once again. Okay, I like that. I like to use it a lot. And name. And then I'm just going to log it just so we can see what's going on. So that should work. Yeah, why not? That should work. Okay, and we'll go back over here to our thing1 and we'll do a get mapping and we'll say thing2s. Clever, right? So thing2, we'll get back a flux of thing2. Come on. Happy, get thing2 listing from thing2 service. If you can't have long method names, what good is it? How much fun is it? So return client.get, and I'm going to add on the URI once again. And what would I point that to? Thing2s slash thing2s, and we'll retrieve that and we'll convert the body to a flux, in this case of thing2. There we go, and we'll log that as well. Okay, so let's restart that, and let's restart this. Not sure if I did that or not. Nope, doesn't look like I did. So we'll restart everything. Restart all the things, yes. My poor machine. On the bright side, you know, if I find that running this just, you know, saps the machine too badly, then I don't know, maybe it'll fall over and give up, and you know, we'll look at a nice 64 gig Linux box or something. I don't know. Okay, so we're running. Let's see. So let's try the I'll do the thing 2. That should work still, and of course it does. So what was it, thing 2s? It was thing 2s. So yeah, so we're getting back our listing of thing 2s. As I say listing, I don't want to say list because it's a publisher, it's a flux. And I sometimes kind of like loosely refer to that just for convenience as a reactive list. It's not, but it's a reactive streams publisher that again can be returned. In this case, we have 5 values. It kind of makes sense just to throw them back out there because it's a small number. But if you had a large number of values or there was a lot of latency or delay between them, you probably would want to make some accommodation for that, right? So let's say if I wanted to, let's see, so thing 1. So I just wonder if I can do this. Let's try it. Let's delay elements, duration dot of seconds, and let's produce 1 per second. I think I'll do something more like this on the back end here momentarily, but I just kind of want to show you the reason this is important at times, or different things are important at times. So let's see. Oh, and actually, one step at a time here. Yeah, I keep thinking of things I want to talk about, and I want to get ahead, and then no, hold back. So, okay, so I'm going to do the same thing again. I'm just going to query that, and you'll notice it's taking a long time, and you're seeing down probably at the bottom, it's requesting the next thing too, and it requests all of them, and only on complete does it finally produce anything at the front end. And that's just because that typically in any kind of a conversation, if you will, until the body is complete, nothing happens, nothing is processed. So what we want to do is be able to process these as a stream. And I'm going to say that this returns a media type, if I can type, come on, oh, produces, I'm getting a little ahead of myself again, produces equals media type dot text event stream value. And this will say, what this indicates is that if you don't indicate that it produces a media type of text event stream value, what it does is produces application JSON. And again, it waits for the entire body to be complete before it sends back anything. We don't want that. We want to actually stream out values as they come in. In this case, we're delaying elements 1 per second. We don't want it to wait until all, 5 elements are back before we return anything. We want to send them out as they are ready. So now if I go here, and what I'll do is just add in the thing with HTTP where I can stream or expect a stream. Then once we're back up and going, looks like we're there. So I'm going to process each one as it comes out. Boom, 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 boom. Okay, so yeah, so it's nice not to wait. And of course, server sent events works with blocking code as well as with non-blocking, but it provides a good way especially for a publisher that is sporadic or maybe delayed to filter results out as you go as well. So, okay, let's see. So that's not terribly interesting, but it builds up nicely for the next thing, I think. So let's see. So we only had 5 here. We're just producing alpha through echo, right? But what if we have more? So I'm going to do something that I kind of think is fun. So private random RND equals new random, boom. And then let's create another endpoint. So get mapping / thing to stream. Why not? And we're still going to be producing a flux of thing 2s, right? So get thing to stream. But instead of just returning a small number, and by the way, this is taking a blocking stream and producing a flux from it. So even that's a little artificial, but it serves well to illustrate the point, I guess. But here, yeah, what I want to do is just return we'll start with a flux.interval. And once again, we'll use a duration of once per second. And then I'm going to map the pulse that comes out of that. It's just a long value, and we'll say, so let's see, I think I need to produce a flux.just. Yeah, let's find out. And I'll just jump up here and do that. Why not? Seems like it should work. Yeah, so names dot get, and we'll just do a random next int on names dot size. Will that work? Make sure I match up on my man, that's definitely not happy. Hold on. Oh, yeah, I'm inceptioning already, so that's probably not great. So let's just cut that out and do a new thing 2, and we'll just go back to our thing 2. Whew. UID toString names dot get random next int names dot size. Oh, yeah, I want to keep the log there. Okay. Seems like should work. Why not, right? Now, the other thing that we need to do, though, is once again, this produces a media type. So we're not waiting around all day for this, right? Because this will go forever. Because as many pulses as it creates, which is infinite, it will go ahead and create another thing too and push that out the other end. So probably don't want to wait until that's done before we start reading any of those. Let's see. So here, let's do this at get mapping, and this will be /thing to stream and produces again because we're going to want to stream this out the other end. Produces. Come on. There we go. Thank you, IntelliJ Media. It's not IntelliJ's fault. I'm just, like I said, working the computer a little too hard. So, well. It's good for it. Exercise is good. So get thing to stream from thing to service. Service. Beautiful. Okay. Return client.get dot URI, and it was thing to service, right? Thing to stream. Oh, I kept it consistent above. Why not here? Retrieve. And body to flux thing 2 dot class, and we'll just log it. Beautiful. All right, let's restart that. Time for more coffee. The little machine that could, almost. Okay, so thing to stream, wasn't it? Now my watch is telling me it's time to stand up. Don't you hate a bossy watch? Just very, very demanding. It's telling me, hey, look, stand up. You really need to stand up. I could turn on the motorized desk, but I'm afraid that would interfere somehow, so I won't do that right now. Okay, so we see that it's coming back just fine, and which is exactly what we expected because things always go right in live coding, right? But we see that we're actually just pushing out a nonstop stream of thing twos, and we're making those available again via server sent events, so they're coming back. Everything's coming through, and as each one becomes available, it's being pushed out, and as each one becomes available, it's being read and displayed here. So that's cool. All right, so that's let's see. So that covers blocking reactive server sent events. Yeah, I'll probably, we've got roughly 9 minutes plus or minus. I mean, we can go over a little, we can go under a little bit, but what I do want to do is show a little bit of RSocket because RSocket I think is super nice, super useful, and just getting more so by the day. So let's see here. So let's see. So, all right, we're still, okay, so we're still good on comments for the time being, so that's good. All right, so let's go back to here. I might as well stop that, I would know I'll need to. So, With RSocket, let's just make this. Here's something I do, and I, everybody has their own preferences, but REST controller. If you look at REST controller, what it has in terms of its it is a meta annotation. I guess let me back up and say, and what it involves, what it encompasses, are a couple things in particular: are controller and response body. And this just means for a REST controller to, instead of expecting to add a particular, let's say, an object to a model to pass back, you just return that object itself, typically with JSON, via JSON, in JSON format. I can't even talk today. But it is a controller. It's still a controller at heart, and it's just we're adding in that at response body when we do that for a streamlined, simplified experience. But what I'm going to do is strip that off, and I'll show you why momentarily. But that requires, of course, that I add the response body to each of these methods that I want to return an object or objects directly. And that's fine. That's that allows me to do this. So I want to be able to put a message mapping in here in the same controller. You don't have to do this. You can have your RSocket controllers separated. I just like to keep the controller together, especially in simple examples like this, because it keeps kind of everything in one spot. So that's kind of nice. And let's just start off returning a thing too. So let's see. So I'm going to return a mono of thing 2. And we'll do basically the same thing we did up here, right? So just return. In fact, why don't I just copy this? Why not? All right. Don't tell anyone, right? So get thing 2 RS for RSocket. Yeah, so easy. All right. This is a via RSocket. Yay. Okay. Now, the other thing that I have to do, and this is crazy complex, it's just mind-bogglingly difficult, but in order to activate this as an RSocket server, what I need to do is do this. I need to designate a port. I know the workload is just terrible, but anyway, this is enough with Spring Boot's auto configuration to understand that this is an RSocket server, that you're wanting to expose things via RSocket, have this listen for requests on this port 8091 right there. So yeah, so we'll go ahead and restart that. Our work here is done for the time being. We'll go back over to thing 1, which is a little bit more involved here, the things that I want to do. So so what I want to do, we'll keep this again fairly simple. I'll just go up and create a component. Can't spell. Typing helps, and we'll call this our RS component. Typing's hard. So we'll have a private final RSocket requester. We need to have a requester so we can use that. And then what I want to do is create a RS component, and we're going to inject our builder. We'll cleverly enough call this builder, and we'll set our requester equal to our builder. And we will connect via TCP. I'm going to just connect to localhost because that's where I'm running this stuff. And let's see, port was 8091. And we have a winner, 8091. Yeah, correct port is kind of important. And we'll block so we can get back that RSocket requester right now. We won't proceed until we get it. So, all right, now I'm just going to do a 1, 2, 1. We'll start off with that. So I'm going to use the requester, and I'm going to define the route. In this case, it's, let's see, what do we call this? Boom, boom. Thing 2. Can't get much simpler than that. So thing 2. And then I'm going to pass some data, and let's just try it with just nothing. Because at this point, it's not terribly important. I won't add that in unless I have to. But you can pass data. You can pass something and get back something. In this case, I'm passing an empty string. Let's see if that works. Why not? I'm going to retrieve a mono, and it's a mono of type thing 2. And then I want to subscribe to that so I can see what it's doing. And this is a thing 2, right? T2. So system.out.println and T2 plus T2. It's a thing of beauty. Okay. And then of course here, what I want to do is a post construct, so I can just run this automatically, and we'll see what we get. We should have already restarted 2. Let's see, comments. Where would you want to use RSocket? That's a great question. And I'm only now showing just the, well, let's see. Yeah, so here's the result, just before I get too talkative and forget to show it. So we're getting this back. We see that we passed, or we got thing 2 back per our request. So that's nice, right? So that worked as advertised. Where would you use RSocket? Well, RSocket has a lot of different capabilities. I want to, let's see if I can pull this up. rsocket.io. Yeah, so rsocket.io is a site. And I really didn't even cover what it does, did I? So apologies for that. Yeah, so RSocket, as it says, is a binary protocol, which probably gives you an idea that it is the performance is pretty good, right? So it's not text-based. You've got a lot more going on a lot less space, which means typically a lot better performance. It is transport agnostic to some degree, obviously. I mean, obviously there are limits, but you can use it over TCP, WebSocket, singular, WebSocket, and Aeron, at least at this point in time. And here are the kind of interesting things about RSocket. And I do want to stop and kind of back up. As I mentioned earlier, if the things you're using are working, you're not having issues with performance or scalability or resilience, it's probably not I have to do this tomorrow type of thing. But RSocket opens up a lot more solutions to a lot more use cases. So you have 4 different models that it follows, or it provides right out of the box, which is request response. So stream of 1, I issue a request, I get a response, which probably sounds very familiar. Request stream, which also sounds familiar. You request something, you get back multiple somethings, right? A fire and forget, which is nice. You just send it out. You don't expect anything back. You don't wait for anything. You just send it. But the channel, the bidirectional streams, makes things very, very interesting, because you have the promise and the fulfillment of that promise, which is full bidirectionality. You also have, since it's based, and I guess I should back up and say this, it's based on Project Reactor. Sorry to say Reactive Streams, but it's based on Project Reactor itself, the implementation of Reactive Streams, which gives you flow control. It gives you back pressure. It gives you the ability to pick up where you left off if you drop a connection. It gives you the ability to, in a secure environment, for a I'm getting ahead of myself again here. If you have in most cases, when you have a communication that takes place between 2 things, 2 services, one acts as a client and one acts as a server. Let's go back up to our request response and request stream. Obviously, the one who's acting as a client here is the one issuing the request. It gets back a stream of values, or a single value. But the interesting thing about RSocket is the channel. Once the channel is established, it is fully bidirectional. One does not act as the server and one as the client once that connection is established. They're effectively identical. So either one can initiate communication, either one can make a request, or just push, fire and forget, and I probably shouldn't mix those, but it can initiate requests, initiate data pushes from either direction, completely of its own volition. So either service involved in that 2-way street can start things off, start the conversation, or just talk and not listen. So it gives you a lot of capabilities. And where I was kind of going with that momentarily, or a moment ago, that I wanted to kind of stop and divert, is that it gives you some possibilities that you just didn't easily have before, or if at all. So in many cases, for instance, if you have, if you need to be able to reach securely, to reach through and access a distant node, let's say, for instance, most of the time what has happened when you need to be able to push something to a node from a service, a cloud service, or a server in just like parlance, you needed to have the connection open by that client, that edge device, or that end device, that node out there, and long pole, or have something like WebSocket, and then of course check and make sure, and hopefully that picked up and restored connections. But you did a lot of work on the client, on the end node. With RSocket, once that connection is established, the service, the cloud service, can just reach in and say, give me this. So once that connection is established, it can say, hey, I need this from you. Hey, I need this from you. It doesn't have to wait for the request to come in and then somehow feedback, and it's just a cleaner interaction. I'm explaining that terribly, and I'm drawing a blank on how to do better with that. So, but the key point is that once the connection is established, literally the server doesn't have to wait to be asked for something. It doesn't have to wait to get whatever it gets from somewhere else. It can go out and initiate that contact once the connection is established. So it gives you a lot of flexibility and capability. In addition, as I mentioned, it's based on reactors, so that gives you the full power of reactive streams, which adds to the flexibility and the ability to deploy on various different transports. Again, TCP, WebSockets, and Aeron. So let's see. Yep. Where did we leave off? I think I restarted and I just hadn't. Oh no, yeah, we saw this. So that's good. Okay, so one-to-one. So let's go back and we'll do a one-to-many. And actually, so message mapping. I'm just going to grab this. Why not? All right. Do. Boom. And that will be fine, perhaps, maybe. Seems like it should. Oh, let's go ahead and do them. Let's do them all. Why not? I'm not sure we'll have a lot of value in doing this, but why not? And I do still want to get to one of my other favorite things, which is the messaging based. Oops. There we go. Boom. Or do I want to leave that? That's a great question. Actually, you know what I want to do? Yeah, this would be cool. This would be cool. So I'm going to change this. And actually, I need to, don't need this because it's not building on the URL. So that's kind of a pointless thing anyway. So what I'm going to do is do a ping pong. So like the ping pong tables and stuff. I haven't played ping pong in a while. Need to get back to that. But I think this could be fun, right? Why not? So what I want to do is do some kind of a bidirectional, like our channel. So bidirectional channel. Seems like it should work. A flux of thing ones coming in, right? We'll call this thing ones. Yeah, that'll work. Okay. So, so we'll return our thing ones, only we won't return those. What we want to do is do on next. And for each one coming in, I'm just going to grab the thing one and we'll do a system.out.println and we'll say received plus thing one. That's cool. And then what I want to do is switch map. So I want to, instead of mapping something to something else, I want to just create an entirely new map. I'll use each thing coming in and I'll just do a flux.just and we'll do a new thing 2 and uid.random.toString and let's do our thing here. Names get random.nextInt names.size just to again random it up a little bit, and let's log this. That should be fun. Fun is good. All right, so I'm going to go ahead and restart this, and we'll go back over here and I'll kill the post construct here because I want to just do the same basic thing here. So post construct and void one to many and requester.route, and what was the route there? Thing twos, right? So yeah, should work. Thing twos. Is that right? Should be right. So data, and we'll say that this is a new thing one, UID, nope, UID dot random dot toString, and RSocket thing one for the win. Okay, and we'll retrieve a, oops, not a mono, we want to retrieve a flux, and this is a flux of thing twos, and let's subscribe to that. And we'll take our T2 dot print line thing to from thing to service T2. Boom. Okay. So, sure, why not? Let's try that. All right. What's a pirate's favorite protocol? Oh my gosh, I got to stop looking over here at the comments. It's RSocket. Yes, of course. You got me, matey. All right, so, oh my goodness, that was great. By the way, if I say that's great, you probably should question your life choices, because I tell the worst jokes in any language anywhere on the planet. So yeah, I'm sorry to break that to you. But anyway, so we're getting these back. So that's exactly what we expected to happen. So that's good. Yeah, so that's nice, right? So everything is working as we expected it to. Let's go ahead and do this thing now for the ping pong, because that's where I really think it gets fun. So, let me change this. Let me just comment this guy out. So yeah, so we'll make this a many to many. Boom, boom. Ain't it great to be crazy? All right, so, yeah, so click. Where did my mouse go? Okay, so return. Now just requester.route, and we will point to ping pong. Great. Now I want to go play data, and our data will do again sort of what we did before. Flux.interval duration of seconds. We'll do 1 per second, and there we go. And we'll map that value to a new thing one, and that will do once again UID random toString and RSocket socket thing one from thing one service. Boom. Yes, that looks so good. And we'll retrieve a flux. We'll retrieve thing2.class, a flux of thing twos, and let's just subscribe to that. So we'll get back a T2. Now I want to go watch Terminator again too. T2 system.out.print line. Let's see. So let's really kick that over. Why not? So T2 plus T2. Now, this is where it gets kind of fun, right? Because this is a bidirectional channel that we're opening. And once that happens, actually, I'm just sending data from thing one to thing two, and thing two is saying, hey, I got something, and I'm thinking you need something back. So I'm just going to send something back. So we're getting our thing twos back from thing two service. And of course, we see that coming in, we're getting, well, actually, I'm just logging going out. So yeah. Actually, I should have, yeah, it is received. I was going to say, I thought I had put something in there to log the received. So just for fun, just to clarify things a little bit here, I'm going to go ahead and stop that. And I'm going to just not log it. And that way this will clean this up just a little bit where it's showing a little more what I want to show. And then once we're done with that, what I want to do is show you the messaging option. A very simple example of messaging, because I do whole talks on Spring Cloud Stream and messaging, but I feel I would be remiss if I didn't at least show a little bit of it, right? So let's run that. Okay, so we're up and getting our T2s, and we're receiving thing ones, thing T1s, things one. Anyway, so everything is working as we expected, hoped. It's beyond our wildest dreams, and that's just kind of scratching the surface with RSocket. But that's I guess, a good scratch. So let me stop this. All right, now I'm just gonna not do the post construct here. And let's move on to something. Let's do the Spring Cloud Stream. I'm actually a little over what I had kind of hoped for, but we'll do this quickly, right? This is an easy thing to do. So I'm going to create a configuration class, configuration. Okay, typing is hard. All right, so this is our thing to config class. All right. So I do this so I can create a bean. Now I can create a bean up here because, and I love to show this, if you look at the Spring Boot application, it also is a meta annotation. And within that, there's a Spring Boot configuration. And within that is configuration. So that's why you sometimes see people put bean creation methods up here in the Spring Boot application, the main application class. I like to keep things separate because even though I lump everything together in one file for demos, I don't do that in production code. So typically what I have is this broken out into a separate class file. So yeah, you know, it's just a habit, but again, do what makes you happy, and you know, you can get away with it in your team. So I'm going to create a bean. This is thing 2. So I'm going to use this as kind of the origin of all things. So this will be, if you'll pardon that pun. So I'm going to supply values to thing 1, because that's kind of been the model so far, right? Thing 1 asks for a value and gets them, or just receives them from thing 2. So thing 2 is the originator of values. And in my Spring Cloud Stream talks, what I like to do is talk about the flexibility in routing and the options you have, and what, you know, regardless of your underlying infrastructure, if it's one of the supported platforms that provide a binder for Spring Cloud Stream. And there are many, by the way. I always point to RabbitMQ and Kafka, because RabbitMQ and Kafka are kind of the industry leaders, the segment leaders, if you will. They're also open source. They have great performance, great routing capabilities. They're available on numerous different cloud platforms. You can run them in-house. You can run them in a container on your laptop. They're just super flexible. But of course, we also have binders for different providers, different messaging platforms like Microsoft's Event Hubs, Google's Cloud Pub Sub, Solace Pub Sub Plus, Amazon Kinesis. There are others. Those are all partner provided binders, which partner being usually, like in the case of Solace, Solace provides it. In the case of Event Hubs, that's Microsoft who provides it. So these are not just things that somebody has spun up on a weekend and got bored and hasn't maintained, right? These are active going concerns. But of course, RabbitMQ and Kafka, we handle directly, of course, working with the respective teams and within the Rabbit team and of course the Apache Kafka folks. But yeah, so Spring Cloud Stream allows you to abstract from that while still getting access to all the goodies underneath. You can tweak it to your heart's content. But usually what you want to do is, again, like we've been doing, is just communicate. You just want to pass something from one place to another and have it, you know, you send it, you have it caught, and it shows up where it's supposed to be. And of course, with Spring Cloud Stream, you can define all kinds of very intricate routings, and you can follow certain predefined patterns, well-established patterns. You can create your own brand new patterns, and that's great. If you do, that's great. You have a very complex and interesting problem domain. Super. You may be ahead of the game on that, but certainly there are a number of patterns that are implemented already that probably cover 98% of the use cases out there. So with a supplier of values, I'm just going to create a supplier bean, and this is going to supply a flux of thing 2s, let's say. Wow, it's not even going to prompt me yet. Okay, so send thing 2s. All right, so a supplier is what? It's a functional interface with a single abstract method, and since Java 8, what can you do? You can provide the implementation of that. So we're going to return a supplier here. So yeah, let's see. So return flux dot interval. Let's do that again. Why not? And I'll just grab some of this stuff down here. Why not? Boom. Yeah, this is sloppy, but yeah, I'm just riffing. So flux.interval duration.of seconds. You know, I don't even need to do this. I really don't. yeah, so why don't I just make this as simple as possible, but no simpler, right? Yeah. Yeah, I guess I will. Why not? That's probably still the best way to do it. So flux.interval, duration of seconds, 1, not 12. I wouldn't matter, right? And we're going to map, and we'll do a new thing 2. So uid.random.toString, and names.get random.nextInt names.size. I'm not sure this will work though. And let's log it. Why not? Okay, so why not? No risk, no reward. So with Spring Cloud Stream, what I want to do is define my binding. Now this is a supplier, right? This is a source. And as a supplier, it has output channels only because it's supplying those values. And we name that channel based upon our, based upon our supplier bean that we're creating. So we have output channels and in some cases input, but again, this is a supplier. It only has output channels. We have up to 8. In this case, we're keeping it simple. We have 1. I'm going to set the destination to just sync. We'll call it sync, and it'll send that there. And then I'm going to also set my binder because if you recall, let's see, there we go. So I have stream, and stream will look for a binder, but I have 2 binders here. I like to do this because I think it's kind of fun. But I have 2 binders here. One is Kafka and one is Rabbit. I want to actually indicate that I want to use Rabbit so I can have those both there and give me some more flexibility. That's probably all I really need. So let's go back over here to thing 1. And yeah, let's just go up here and we'll do @configuration class thing 1 config, and once again create a bean. This is a consumer of a flux of thing 2s, right? That's what I'm passing. There we go. Import. Be happy. All right, so let's say we'll just show thing 2s. And with a consumer, once again, functional interface, single abstract method, we're going to accept a value, so return, and we're getting a flux. Well, that'll work, thing 2 flux, right? And we'll take that flux and we'll just subscribe to it and we'll print it out. Oops, I wonder what happened there. Must have tapped the wrong key. Print line. Okay, and then what I'll do is grab this, and once again, Spring Cloud Stream bindings, and we have an input channel in this case, a single one, destination. This is coming to sync. And I'd actually thought about, should I have had time, to set up a fan out pattern, but that actually would require more work than we have time at this point. So it's not the end of the world. So let me copy this, binder equals Rabbit, and that's should be enough. So let's go ahead and start our thing 1. Make sure I didn't miss something crazy. I did. Clearly I did. Connection refused. It's trying to go to 8091. Well, let me just comment all this out for the time being. Comment out my RSocket stuff while I move on to other things. That seems happier. All right. So we see that we're subscribed, and that's good. So let's go back here, and that tells me I probably want to, we'll just run it. What's the worst can happen, right? Stack trace. We can fix that. Okay. So let's go back here, and we see we're getting values. So that's good, right? Now, something that I do sometimes, or I don't do, but I get asked about every so often, and I just never have the chance to do it, is, I'm pointing to a local instance of RabbitMQ, right? I'm running Rabbit in my in a container running on my machine, which again, I'm running 3 or 4 containers as well. So wonder why my machine would be bogging down. But what I kind of like to do, let me see if I can find the connection strings here. Because I have those written down, well, typed. I have those somewhere stored. What I like to do, I switch to Kafka from RabbitMQ, which I can do here momentarily. But what I also like to do is any valid RabbitMQ instance or Kafka instance works just as well. And I'm going to point to a cloud-hosted instance here. Let's see. So I've got my, I don't have my host. So I need to grab that. And yes, I'm showing you my deep, dark secrets here, but trust me, this is the free plan, so you're not going to get anything from that. And let's grab that. And we'll restart thing 1 so it's ready and waiting. We'll go over to thing 2. So what I'll do is just point this to a cloud instance, a cloud-hosted instance, just on a third-party cloud AMQP. Say that 3 times fast. And that allows us to use, again, to point to Rabbit anywhere. It's 4 properties. You point to the RabbitMQ host, virtual host, username, and password. And then regardless of where you're pointing, as long as there's a valid instance there, it picks up and goes where it left off. So there we go. Yeah, super nice. Now, if you really want to go back, let's do that. Why not? Because we have like 1 more minute. Why not? So I'll just get rid of that. And then I'm going to just point to Kafka. I always like to auto add partitions, and just out of a point of habit, minimum partition count of 4. It's not the end of the world. We need to tell it to use Kafka. Because if we left it at Rabbit, it would do no good whatsoever if I'm switching everything to Kafka, right? All right, so open application properties. And Spring Cloud Stream Kafka, auto add partitions true. That just allows our application stream, Spring Cloud Stream, to go ahead and add partitions should it need to. Oh, and once again, I almost forgot to change this over to Kafka. So this is a nice feature of Spring Cloud Stream because again, if your pipelines change, if your underlying messaging infrastructure has to change, needs to change, if you need to integrate with other like customers, partners, acquisitions, or if your company is acquired by somebody else, it gives you a lot of flexibility as well. I haven't even covered anything in terms of the routing flexibility that it gives you, which is amazing in and of itself. We see that we're pushing values out and we see that we're getting values. So very quickly, I showed you 2 points, a supplier and a consumer. But you can have, just out of the box, you can have access to functions in between, transformers, as I like to call them. But in the old parlance, the legacy API of Spring Cloud Stream, and I say old, legacy, there's nothing wrong with it. It's still being supported. But you had a source, a processor, and a sink. And that made a lot of sense because the source is the thing where values originate. A sink is the end of the life cycle of those values. And in between, you may have multiple, 1 or more, processors which transform that in some way. If you go down to the language level, Java in this case, you actually have the same concepts in terms of suppliers, functions, and consumers. So that's kind of the API going forward. It's a very clean, non-leaky abstraction type of API. It keeps things as close to the language and metal, if you will, as possible. And it's very, very nice. And again, flexible because you can have multiple transformative agents in between. You can chain functions within a transformer in the middle, or you can chain the actual applications and tie them together via various different mechanisms, different messaging pipelines. And I do try to stay at the higher level term pipelines because whether you're using Kafka in your topics or RabbitMQ and exchanges and queues or something else entirely, the fact remains that when you're passing messages, you want to connect one point to, or multiple points to other multiple points, potentially one-to-one, one-to-many, many-to-many, whatever. And that allows you to do that incredibly flexibly. So with that, I think I will probably just call it. I'll go over and check now the comments, the questions. And let's see. So thing 2 I've shut down. Might as well take as much strain off the laptop as possible. And shut that process down. Okay, let's see what we've got here. All right. So those of you who have stuck with me to the end, this has been fun. It would have been more fun if we were sitting together, drinking coffee together and coding together. But for now, this is where we are, and it's good stuff too. So let's see. Let's see. Okay, I'm going to try to blow that up. Yeah, that's much, much more readable. Okay, so my jokes are at the same level as Vogue on Poetry. That's actually the nicest thing people have told me about my jokes. And if you're not familiar with Vogue on Poetry, you need to read The Hitchhiker's Guide to the Galaxy. All 5 books now. I used to always say it's a trilogy consisting of 4 books, but actually, toward Douglas Adams' later years, they slipped in a 5th book. So, Vogue on Poetry is legendary for, just to explain what a Vogon is, it's an alien who is super good at bureaucracy and being, they're great functionaries. They're terrible at poetry, but they love it. They love to recite it, compose it, recite it. And when they recite it, people like claw their own brains out. It's just terrible. So my jokes are on that level. And again, that's a step up from where I have been. So thank you. Let's see. When would you start using Kafka RabbitMQ? At what point should an application use it? If message loss is a real problem. There's so many answers to that, and a lot of them depend on circumstances. So the first answer is it depends. That's always the answer. But to kind of explore my thinking on the topic a little bit, everything that I showed you in the first part of that, all the way through RSocket, it's basically talking about 2 points. You have a service talking to another service, and it's incredibly, especially when you talk about RSocket channels, the bidirectional streams, it gives you a lot of capabilities. But remember, you're still just talking 2 things. So when I think of messaging platforms, and of course you can do 2 things on messaging platforms too, and you can chain together things via other mechanisms as well. But with messaging platforms, the big thing I find is the ability to decouple your producers of messages, your transformers of messages, and your consumers, which gives you crazy flexibility. You can scale any of those points. So if you have a producer, let's say you go through 3 different transformers, and then you hit the end of the life cycle consumer that consumes it, and that message is done, you can scale at any step along the way. So if that second transformer is heavily overloaded, you can scale that out without scaling out anything else. So it gives you a lot of flexibility that way. It also gives you, again, those patterns, because if you want to send a message, let's say you take an order, and that, you have an online brokerage company, and you take an order, and when you receive that, let's say a stock purchase order, and you get that order, then obviously it's important that you execute on that stock purchase, but you also perhaps want to send the same, hey, I've got this buy order. You want to send that not just to the trading module, but you also want to send that to somewhere else so it can be logged or checked or audited or what have you. And then of course, once that trade is complete, it may send to various different downstream transformers / consumers. So you get crazy flexibility in terms of the patterns you can implement that you just don't have when you're only talking a point-to-point communication. And you've got things like the durable queues, the dead letter queues. So if something is incomplete, malformed, whatever, you can actually act on that automatically, or even should things go badly enough, manually should you need to. So it gives you a lot of flexibility that just is unequaled in, as far as I'm concerned, or aware in any other way of doing it. So, let's see. We will have coffee together again. I'm confident of that. I'm not confident of the timeline, but it's bound to happen. So, let's see. So, Adam's book too. I'll have to look at that. Let's see. If you were a transformer, what object would you transform into? These are tough questions. I don't even know where to go with that. I don't know. I saw something, speaking of transformers, I saw something the other day about this massive multi-floor Japanese transformer that was built. And maybe that. Those of you who know me know that I like to say fun size. I The fact that I normally, in a normal year, travel a lot, it works out fine because I can fit in overhead bins quite nicely. But yeah, so yeah, probably this big, the big transformer. Why not? Studying contrast. Okay. Well, with that, I guess we'll wrap it up. But thanks everyone for coming. And yeah, we'll try this again. Thanks for your patience. Like I said, some of the things that I'm still, they're half-formed thoughts. I'm kind of working through them. I'm seeing where they go. So once things kind of settle in and I get a complete talk or two, I'm looking at actually a couple talks out of this type of material. Then maybe you can come back and tell me how I did. So appreciate your time, and we'll look forward to seeing you again maybe next week on Code. That's a Gundam, not a Transformer. Oh, sorry. You asked my choice, so I'm still going to go with that. All right. Hey, thanks so much. Take care, everyone, and we'll see you. Hey, see you on Twitter, right? Let's keep in touch. Ping me, MKHeck. Follow me if you have public stuff you want to talk about. That's fine. DMs are open. If you get to me before I can respond, and follow back. But yeah, keep your head up, keep safe, keep masking, keep coding, and we'll talk to you soon.